Hi everyone, I'm Olivier Laurent. I'm going to present you learning to generate training datasets for robust segmentic segmentation. It is a collaboration between Paris, the National University of Singapore, and Value AI. So for the context, as you know, segmentic segmentation models have really progressed recently. However, they still struggle when they are faced with outliers. And outliers are objects that haven't been seen during training. This is very difficult to cope with, and it remains a problem in safety critical applications. And I'm going to give you just an example on the right here. You can see on the video. So this is a Tesla, and something weird happens on the screen with the detection. And you see that it's because of this truck that carries traffic lights. So this is a very rare event. Still, it may happen, and we have to account for those type of events. So in this paper, we propose to improve the robustness of segmentic segmentation models without computational overhead. And this is thanks to a new strategy that we propose that is based on the functional symmetry between label-to-image models and image-to-label segmentation networks. We also propose the first framework to evaluate the robustness of label-to-image models against perturbations, as well as a new architecture, a cascaded conditional GAN, that improves the robustness of the generative models compared to model conditional GANs on the framework that is proposed just before. So I'm going to start with explaining this strategy, which is quite simple. Actually, it's only 3 steps. So we start with a datasets of semantic segmentation, and we train a generative model between the labels and the images, that is a label-to-image model. And then what we can do is to add perturbations on the label maps. And if we add these perturbations, we're going to also have perturbations on the resulting images. And finally, the first step is to use these images with perturbations to train a segmentation model. And we show that we can improve the robustness of these models doing so. One key aspect here is that we need to have label-to-image models that have a good robustness when they are given label maps with perturbations, because we want the quality of the images to stay. We want to keep a good quality of images in the to train the segmentation model afterwards. So I'm going then to present our new architecture, Robusta. That is a CN cascade, and that is we show more robust to perturbations in the label maps. So here is just an architecture in 2 steps that are trained sequentially. What you see on the left, that we concatenate the latent spaces of a convolutional and transformer generator. And we show in our paper that it improves the robustness of the architecture. So with Robusta, so now that we have Robusta, we can test it, but we have to devise a new framework to test actually the robustness of label-to-image models, because this had not been done before, to our knowledge. So what we propose is to create 3 datasets with perturbations. And we propose 3 different types of perturbations: in distribution, out of distribution, and objects added to the label maps, and morphologically dilated objects on the label maps. And if we apply it on cityscapes, for instance, we are going to have corrupted cityscapes. So it's when we add in distribution objects to the label maps. We're going to have outlier cityscapes with out of distribution objects on the label maps. And finally, morphological cityscapes. Here you see the translation coming from the original labels on the left, and on the right, it's after this perturbation with morphological dilation. So you see that all the objects are a bit bigger. So when we have done this, what we do is that we measure both the FID of the translated images, the pressure inception distance, and also the mean intersection of their union of a baseline segmentation model trained on cityscape. So if the translation is good, we expect this intersection of our union to stay relatively high. Okay, so now we can just give you quickly the results of the experiments. And you see here that Robusta, so it's both lines on the bottom, obtains better performance than current conditional GANs, Spade, and Oasis. So this works on the corrupted outlier and morphological versions that I've presented you just before. So it's for state escapes and AD20K. We also show in this table that it is really important to have both the two generators, so G-coarse and G-fine, that improve a lot the results. So this is for the label to image robustness. And then, if you remember, on the first step was to try to train segmentation models using images from generated by Robusta. And we show here that the performance on epistemic uncertainty, that is the detection of outliers, is improved. So it's also the final two lines here of suit hazards and BDD anomaly. And we see that we have improvements on the detection of anomalies. So for the mean intersection of a union, it's just that we use the simple baseline as to do the semantic segmentation. So it cannot be improved over the baseline, and it's a bit worse than ensemble methods that use 4 baselines and average the results. But our method is still better with the same inference cost as the baseline to detect anomalies. Furthermore, we also show that our semantic segmentation models are also more robust on when given datasets with perturbations, for instance, rainy cityscapes, cityscape C, and foggy cityscapes. And all of this with the same inference, without inference overheads compared to the baselines. So, which is not the case of LPBNN, deep ensembles, patch ensembles that are heavier to run. So finally, for the conclusion, we have seen we show in this paper that we can leverage label to image translation generative models to improve the robustness of image to label segmentation networks with this new strategy. We provide a new framework to evaluate the robustness of these generative models. And finally, we also propose a new CGAN cascade that improves over prior works in image quality and robustness as measured by the aforementioned framework. We intend to build on this result with stronger diffusion models in the future. So thank you very much for listening to me, and have a nice conference.